So today we will solve this inequality, and this is actually from the Oxford Physics admission test. So I figure it would be much interesting if I invite a physics teacher. That's why I'm collaborating with one of my friends, Zed Physics. He also has a YouTube channel on physics, and you guys should definitely go check that out. Right now, let's go ahead and see how he will solve this question for us.
I normally teach physics on my channel Z Physics, but today I would like to thank Black Pen, Red Pen for having me on this channel. Let's do some maths. So what we're going to be solving today is actually an inequality from the Oxford Physics admission tests. We have a compound inequality and -1 has to be less than -1 over x plus 2x. So if we were to split the inequality into two parts, let's just rewrite them out over here. Let's say that the first inequality is going to be -1, which is less than 1 over x plus 2x. Rather than multiplying by x, which could be positive or negative, meaning that the inequality sign would flip depending on which one it is, I'm going to do a little trick and I'm going to multiply this by x squared. X squared will always be positive, and this is a little trick whenever we see 1 over x in inequalities. Okay, so what are we going to get? We're going to get minus x squared is less than minus x, and then we're going to get plus 2x cubed. Okay, let's tidy this up a little bit. So 0 has to be smaller than minus x plus x squared plus 2x cubed. We can also rewrite this as 0, which is going to be smaller than 2x cubed plus x squared minus x. And now we can just factorize an x. So 0 has to be less than x, 2x squared plus x minus 1. So now we actually have x which multiplies a quadratic, and what we really want to do is find the roots of this quadratic. So we can just factorize that. We can say that 0 will be less than x, and then if we factorize this, we're going to get 2x minus 1, x plus 1. I think that's right. Let's do a quick check. Yep, that's fine. The quadratic over here will end up having roots at x is equal to 1/2 and also at x is equal to -1. And now we can consider a couple of different cases. We want this whole expression to be greater than 0, meaning that if x is positive, then 2x squared plus x minus 1 will also need to be positive. If x is negative, on the other hand, then this quadratic will also need to be negative. So let's start off with the first case, in which let's say that x is less than 0. So if that's the case, what we want is the quadratic to be negative. Well, what will the quadratic actually look like? The easiest way is just to sketch this. So it's going to be some sort of a quadratic where this here, let's say, is y of x, and it's going to have a roots at 1/2 and -1. So here is -1. And let's say 1/2 is somewhere over there. The function itself should look something like this. We don't really care about anything else other than those two roots. So if x is less than 0, we want the function to also be less than 0. So that would mean that in this case, we want this region in which the quadratic is also negative. The quadratic is negative across all of this region, but we know that x is negative, so x really should be anywhere between -1 and then 0, because this region here is the only one in which x is negative as well. Let's consider next the case in which x is positive. So if x is greater than 0, then we'll also need the quadratic to be positive as well. In other words, we're going to be looking at these regions over here. Now, we can sort of forget about this one. Why is that? Because x is greater than 0 in this case. So what we're left with is the region between what is it, a half, and then all the way up to infinity. It might help us later actually just to say that x will be the intersection of those two intervals, a half and then infinity. This of course being a compound inequality, we've only really done about half the work, maybe even less, so we've got more maths to do, which is great. So let's see what else we need to satisfy. Minus 1 over x plus 2x has to be less than 1. Let's tackle this one as well over here. I'm going to once again do the little trick of multiplying by x squared being always positive. So now we're going to get minus x plus 2x cubed. That's going to be less than x squared. Minus x plus 2x cubed minus x squared is less than 0. Now let's just tidy this expression up a little bit. So we're going to get 2x cubed minus x squared minus x is less than 0. Take a factor of x out, and now we have a quadratic, yet again, very similar quadratic, 2x squared minus x minus 1 is less than 0. We are once again going to take exactly the same approach, but now we need to make sure that x and this quadratic have opposite signs because we want the overall expression to be negative. Let's figure out the roots of this one and factorize yet again. 2x plus 1, x minus 1, I think. Let's just double check once again. 2x squared. 1, yep, that seems fine. This whole thing has to be less than 0. Okay, so this quadratic here is going to have roots at x minus half, and also x is equal to 1. So let's take a very similar approach yet again. So here's our quadratic. It's going to pass through minus a half. And then it's also going to pass through 1. When x is less than 0, the quadratic is positive in two regions. It's positive over here, and it's positive over here. We can kind of forget about this region though, because x has to be less than 0. So we're only really going to consider, well, we can just write down that x is going to be from negative infinity sandwiched between minus a half. I think that's right. Okay, now if x is greater than 0, that would mean that the function will need to be negative. And if the function is negative, it needs to be in this region over here, right? But x is greater than 0 only in this region of the function over here. So that's between 0 and 1. Okay, that's a nice little interval. So x is going to be between 0 and 1. So between 0 and 1, yep. So x really is in the intersection of these two intervals. Okay, now we have to satisfy both this condition, but we also need to satisfy this condition as well. So what I'm going to do is I'm going to write them on one page and see what sort of interval that gets me. I'm probably going to sketch something, try not to confuse myself. So both of these conditions actually need to be satisfied. So let's draw a little number line and see what we actually get. I'm just going to place all the numbers that we can see over here. So let's say this here is 0. Let's say here is minus 1. Plus 1 is about here. We're also going to have minus a half. We're also going to get plus a half. First interval was from minus 1 to 0 across here, and then from a half pretty much onwards. Our second interval, let's use this color for that, is going to be from negative infinity to minus a half. So somewhere across here. We can already see some bits that actually overlap. And then we have from 0 to 1, like that. So the points at which those intervals overlap are going to be, well, here. So x is going to be between -1, -1/2, and also here, which is going to be from +1/2 to +1. That's pretty cool.